Hokie dokie. In this problem, they give us 3 statements, and the goal is to identify which of these are true. So some notes or some things to remember. Differentiable means that the derivative exists. And oftentimes in this question, they'll represent the derivative of a function using our limit as h approaches 0 of the difference quotient. Another thing they'll mention is, some function has a derivative at all values except something. So this is just an example. If we have the function 1 over x, it will have a derivative at all values except for x equals 0. Why not? Or why x equals 0? If we plug in x equals 0 here, we'll have 1 over 0, which is an undefined function. So it's kind of a result of the function being undefined. Because it's undefined, at 0, it will not have a derivative at 0, but it will at all the other points. Same thing with this one, just to include a second example, f of x equals 1 over x minus 8 will have a derivative at all values except x equals 8, because if we plugged in 8 into that function, it would give us 0 in the denominator, which would create an undefined function value. So let's jump into it. Number 1. If this limit exists for all x, then g is differentiable. This limit matches the limit we see here with the difference quotient spot on. All the important pieces are right. It's h approaching 0. It's x plus h minus g of x all over h. And so what this is the derivative of g. So if the derivative exists for all x, then g is differentiable. Well, differentiable means the derivative exists. So they're basically saying if the derivative exists, then the derivative exists. So that's true. Number 2, the function. Negative 4z squared has a derivative for all values except 0. So again, our test is to just plug in the value they tell us and see if it's defined. If it's defined, then it should have a derivative in these cases. Not always, overall, but for these problems, that's all we need to do. So when we plug in 0, we'll just get 0. And so that is a defined value, so it will have a derivative. So actually, they say except 0, so that is actually false. Got a little confused. All right, number 3 has a derivative for all values of r. This is true. So this is pretty much the same function, and we found that when we plugged in 0, we got 0. That's a defined value. It's not undefined. So this one is false, while this one is true, because it does have a derivative for all values of r, because there's no r value we could plug in here to make it undefined. All right, so only 1 and 3 are correct. Break out the eraser to see that F is our answer. Let's go ahead and do 2 more of these following these same notes here. The function negative 7p minus 8 has a derivative for all values of p. That's true, because there are no values of p we could plug in there to create an undefined function value. Number 2, if this exists for x equals 0, again, this means the derivative of f in this case. So they're saying if the derivative of f exists for x equals 0, then f is differentiable at 0. That is true, because differentiable means the derivative exists. And so derivative exists at x equals 0, it's differentiable at 0. That's very true. Number 3, if f of x equals 1 over x, then f prime, again, also meaning the derivative of f, is equal to this. So really the question is, does this match the form f of x plus h minus f of x all over h for this function 1 over x? So if we use this function to come up with this, does it match what they have? Well, let's do it from scratch. F of x plus h means we plug in x plus h where we see x in this function. So it's basically 1 over x plus h, and then we would subtract f of x. And f of x is 1 over x. And then we'd have all of that over h. So really, this is what we should find here. But that does not look the same. So number 3 appears to be false. Looks like 1 and 2 are correct. Break out the eraser to see that D is our answer. Let's go ahead and do one more. The function 1 over t minus 8 is not differentiable at t equals negative 8. So what we check for is when we plug in negative 8, do we get 0 on the bottom? It's kind of close, but in fact we actually get negative 1 over 16, which is still defined. So it actually is differentiable at negative 8, but it's not differentiable at positive 8. If we plugged in positive 8, we would get 0. And so if it had said positive 8, it would be a true statement, but instead it's false. Number 2, the function t squared is differentiable. So to be just differentiable means the derivative exists at all t values, which is true because there are no t values for which this is undefined. If this, again, which is the derivative of f, exists for x equals 1, then f is differentiable. Again, differentiable with no definition of like for certain x values means differentiable for all x values. So they're saying if the derivative exists for one value, then it exists for all values. Not true. If it had said differentiable at x equals 1, it would be true. But you get the idea. All right. So it looks like just 2 is correct. Break out the eraser. See that C is our answer. If you have any questions or they throw any curveballs at you and this video doesn't quite help answer whatever that statement is, please let me know and I can address it.